Hello everyone and welcome back to my channel and welcome back to a new video. So in today's video we're going to be talking about Newton's third law of motion and the action and the reaction and the vector pairs. So what Newton's third law states is that for every action there's an equal and opposite reaction. Now this statement is really used in everyday life, but the only difference is in physics is that we relate it to a specific scenario that occurs whenever two objects are acting together or are working together or are in motion. Now with this theory, Newton's third law states that whenever two objects interact or they collide with each other or they ever come into contact with one another or another surface, it means that the amount of force that one object exerts, the same object or the opposite object will exert the same amount of force, but it will be in the opposite direction, and the amount of force exerted will be equal on both parts. So if you take this example over here, we have a car colliding into a wall. Now, with this theory that states for every action there's an equal and opposite reaction, as the car is colliding into the wall will simultaneously, at the same time as the collision, exert that same amount of force that the car exerted on the wall will exert it back onto the car, but this would happen quickly and it would happen simultaneously. This is where you'd get that impact of the car crashing into the wall. Now if you really think about it, these two forces come in pairs. Since the vectors sum are equal and opposite, the vectors are the same length, they contain the same amount of force, but the only difference is that they act in different directions. So for example, I've got a vector over here, and I'm going to say that this vector has a force of 5 newtons. So 5 newtons in this direction means that it will also exert the same amount of force in the opposite direction. 5 newtons as well. So what that basically means, if this were to come into contact with another object, this would also be 5 newtons. Likewise, or like so on this side, that is also 5 newtons. Now in this specific scenario, this is in relation of two objects acting together. So in this case, we would ignore any other forces that are present there, because what happens is that the vectors are coming in pairs and there's no isolated force whatsoever. It's just those two forces acting together and they would be coming into contact with one another. Now if we were to look at an example of a rock falling on the ground, this particularly means that the rock would be exerting a force of 9.8 meters per second, because remember that's the gravitational pull that's pulling it onto the ground. Then simultaneously the earth would be exerting the same amount of force in the upward direction onto the rock as it's falling. What we can deduce from this is that the acceleration is inversely proportional to the mass. The reason being is because the earth is extremely heavy, so its acceleration is negligible, in the sense that whenever a rock or any object is falling on the ground, the Earth's acceleration is negligible because the Earth is so heavy. Hence why we say that the acceleration and the mass of the object in Newton 3 are inversely proportional, because remember, the heavier an object is, the less amount of acceleration it will produce. The lighter it is, it's more likely to have a high amount of acceleration. In this case with the Earth, since the Earth is so big and it's so heavy, that acceleration is particularly negligible. So I hope you guys have enjoyed this video. If you guys have any questions, you're more than welcome to leave them in the comments and I'll most definitely get back to you. Please like, comment, subscribe, and share, and I'll see you guys in the next video. Bye.